Good morning, Zurich. Another year passed with a lot of interesting projects and technologies that have been shown around the world. And it's a big pleasure to host you all again this year here in Zurich, the beautiful city of Zurich. So before going deeply into the presentations and the technologies, and specifically to have a great lookout for the future, because we are talking today about visions, I would like to give some key facts on our conference of today. We have been completely sold out, meaning that we have over 220 participants, about 29 speakers, representing over 100 companies together. So you have great opportunities to network during the break, coffee breaks, and the lunch. And later in the progress, we have also speed dating, where you have the possibility to meet some of the representatives of the companies that also kind of enable this event. We are pretty fortunate actually this year, because the number of participants from abroad have been grown. So this year we have more than 30% of the participants from abroad, US, all around Europe, and especially our beautiful own market, Switzerland. We have a full day catering, meaning that you can always grab something to eat and network. Before we start the event, so a big thank to all the partners and sponsors of the event that enabled today, and also a big thank you to all the speakers of today that prepared in the last weeks the slide sets as well as their presentations. And our day, just to go quickly through it, is kind of split in 5 sections. We are currently in the section 1, where we start the event. Then later in the progress, after the coffee breaks or the lunch break, we have section 2 with essential companies representing novel technologies and use cases. Later in the afternoon, we have a mixture between industry and research. And in section 4, we start the discussion panels with some technology-based companies, I would say, or technology leaders. And we have also special guests today from Flughafen Zurich and Microsoft and Bakery that will present their interesting solution. And later towards the evening, in section 5, we have a second discussion panel and also a closing talk, and afterwards the speed dating will start. And we have again this year a DJ who will actually follow you and make the evening more beautiful to network. So in order to start today's event, Christoph, what do you think? What are the key challenges that we need to solve in the upcoming years, and how does the future look like?
I'm glad that I'm prepared for this question, so that's what I'm going to do right now. Yeah, so let me first start with basically the challenges we have right now in the IoT area. We just brainstormed together with industry and academia what are the key difficulties we have right now. And of course, most of them you're probably aware of. Battery lifetime is an issue. Also coverage and range, that we can reach all the sensors. The cost should be low, reliability should be high. We don't want to do much maintenance. Supply chain was a big issue, is still a little bit of an issue, but there's also other issues like privacy, data management that we have to be careful with. But let me just go into a few of them that we have right now. And of course, everybody knows most of these IoT sensors run out of batteries. Battery lifetime is an issue because if you have to replace them, you need maintenance, of course. And if you have temperature fluctuations or cold weather, aging, these batteries usually can deteriorate faster than you want them to. Fortunately, the battery industry is not sleeping, so we can be quite lucky that they increased the density actually by 8 times between 2008 and 2020. So you can see that. Let me see whether this works. Yeah, you can see this here. And also an idea would be to use rechargeable batteries, so not just throw them out when they're empty, but to be able to recharge them, put them back in. And of course, another way, instead of just improving battery capacity or battery density would be to improve the energy efficiency of the circuits. And of course, here, academia and industry would need to work together to come up with even more energy efficient solutions. And of course, one thing that I haven't seen as much as I want to would be to add energy harvesting to IoT sensor nodes. Light is good, so it does not need to be sunlight. It could also be light in here, for example, that you could use to harvest. You could use radio frequency waves as well to harvest energy and charge your battery, for example. You can use mechanical motion, so there's many different things we can do. So there is hope, I would say, if we work together. Then power dissipation. I mentioned this briefly. We can improve energy efficiency. And everybody probably in here has heard of Moore's law, that the size of transistors shrinks exponentially fast over the years. But it's actually interesting. Even though everybody knows Moore's law, that's not really what's relevant for IoT. We don't really care that much about how many transistors we can cram on a chip, because usually the processing is fairly simple. What we care about is energy. And it turns out there is basically an equivalent or an analogy to Moore's law, which is Kumi's law. Has somebody heard about this in here? Okay, maybe like a half a person. Okay, good. So yeah, basically what Kumi's law states, it's not a prediction. It's actually, Kumi did a study for the years back, and it says the number of computations that you can do per joule doubles every 1.57 years. Of course, it's somehow related. It's also exponentially growing like Moore's law, but it's really what we care about in IoT. And the interesting thing is, if you see the graph on the right, let's see, okay, if you see the graph on the right, let me see whether I can point to it. It actually, this trend is valid since vacuum tube computers. So this is a very long trend. And as I said, Kumi did not predict, he did this backwards, but it actually turns out that this law is fairly stable and also will hold for the future. So there's some hope that energy efficiency improves, and most of it comes from better technologies, but also from better circuitry. So basically, if we want to have sustainable solutions that have low power dissipations, we can a little bit rely on this law, but of course, we're basically all part of this to improve the circuits that we are building. Then another thing, of course, coverage and range is extremely critical. If you have an IoT sensor that is not in range, or you cannot connect, basically it's totally useless, it's an absolute waste. And the idea is like, how can we improve range or coverage without, for example, increasing power that we don't want to do. So there are many possible solutions. One is that it's actually a trend happening anyway with 5G and 6G, and we will hear about that much more when Professor Andreas Burg from EPFL will talk. That there's a trend towards having more dense networks of access points. So this will improve coverage, but also nowadays when people specify new communication standards, for example, newer releases of 5G, or maybe as soon as 6G is getting standardized, IoT is not an afterthought. Actually, IoT will be part of the standardization from the beginning. And there's very interesting ways. I mean, some of these things are already happening right now. You can have like the IoT device communicate within your band, where also like, for example, LTE or 5G is happening, or you can put it between the bands. So these are like kind of like illustrations of the frequencies and the portion allocated by services. So there's solutions, coexistence for IoT and 5G and hopefully 6G. And so there's also hope. And 5G plus will definitely help this increase of coverage. But also, we were thinking a little bit about like what's actually happening in the 5, 10, 15 years in the future, not just like now-ish. And this is out of discussions between academia and the industry, and some of these things you may roll your eyes and think that's not going to happen, but some of these things will happen, and I'm pretty sure many of these things are going to happen. So here's a list, and I'm going over the list, but I'm not going to read it to you. So basically really is like what will happen 5, 10, 15 years out. One trend that is most likely going to happen in the IoT space as well, imagine you have a sensor, it's a very remote area, you cannot connect to an access point because the access point would also need to be in a remote area. What you could do is you could connect your IoT device either to a normal access point, and the access point communicates to satellites, or you can create new protocols to have IoT sensors directly communicate with satellites. So this is really, academia is looking into this. The good thing is you would not need a dense network of access points, and you can get coverage basically everywhere in the world where you have line-of-sight connectivity to satellites. Of course, the problem is IoT devices are low power, so the range is difficult. It's actually difficult to reach satellites. And the other issue is from the satellite side. One satellite may see so many sensors, even though they can do beam steering, scanning a whole area will take too long. So the opportunities are there for sure, but of course there are practical challenges how to connect with satellites efficiently. But this would allow us to place sensors basically everywhere in the world. Another trend, and I mentioned this before, is this network densification. Basically, the idea is instead of having a few base stations in a big cell and they communicate with the devices nearby, one trend is to basically have a very dense network of access points. And the opportunities with this is you can remove the cell boundaries, you don't have to do complicated handover procedures, but also you actually get much better coverage, because it can be that if you place a sensor between two access points, you can communicate to both of them at the same time, and by combining the signals, you can actually get significantly better data rates or performance, and also meaning the sensor can send at lower power as well, which is important. The challenges of this densification is, of course, who's paying for the infrastructure? It's always a question. And then if you really want to get the full gains of this technology, like really taking data acquired at multiple access points and combining it, you need to have cooperations between the access points, and the backhaul needs to be stable. So this is pretty difficult to do, but again, has a huge amount of advantages. Another aspect that I think is overlooked fairly often is IoT devices are more used for critical infrastructure. And of course, if something is used for critical infrastructure, it's vulnerable to attacks. And for example, jammers, but it turns out that you can equip, if you have an access point with many antennas, you can do nulling in space. I can mute certain locations where signals come from, reducing or basically avoiding jamming completely. So there's ways of doing that. Challenges is you need now access points with multiple antennas, and also the computational complexity of the methods that you have to run on the access points is significant. But again, there's ways for this, and I'm pretty sure this is going to be a bigger trend to make these networks really stable in the future. Another trend or vision that something that can happen is using drones or unmanned aerial vehicles for IoT networks. And the idea is basically you place networks or sensors in a remote area, and you have once per day a drone flying by, quickly collecting all the data, quickly dumping all the data that are required, that's it. Think about this really like a the mailman bringing you a letter and you're picking up letters. It's really like this idea. The cool thing with this is you would completely avoid infrastructure, except of a drone that can cover large area. And you could also use the drone or the UAV to drop sensors if you want to. So you can even place sensors at very dangerous locations. And also because the drone can fly fairly close to these sensors, the range of the sensors can be reduced, can improve power consumption, so there's many advantages of that. The issue is the flight times of these commercial drones is still about half an hour, so this is still not very good. And also the payload you can carry and the additional power you can expand is not that great. And of course, if the weather is terrible, you will just not be able to read out your sensors, so that's another issue, but maybe that's fine for certain applications. Of course, intelligence. Everybody's talking about machine learning, and nowadays most of these IoT sensors are fairly stupid. They just collect data and send it to the access point. But if we could enrich these sensors with on-sensor machine learning, the sensors could make autonomous decisions. For example, decide, should I now even send the data or should I wait sending the data? You can make the sensor adapt to the environment, or you can also reduce the data to be transferred, because you can distill the data and really only transmit the essential information to, say, the access point or the network. The problem of this is, of course, it would be really cool if you could do that, but adding machine learning to these embedded devices adds complexity, so you need more transistors, and of course will reduce energy efficiency and also the cost of the device. But of course, I'm pretty sure this is going to happen. The question is just when this will happen, that we have intelligent sensors. Software-defined IoT is another idea. Like right now, most of the sensors are basically hard-coded. They can do one task. But if you imagine you put like a processor or microcontroller on it, like a RISC-V that you can program from far away, you can over-the-air update the sensor. You can improve also the capabilities of the access point and the sensor. You can do these kind of things. But of course, the difficulty would be is again, adding a processor instead of hardwired circuitry is less efficient, so typically you need higher power, could also increase the cost of the device. And also, like for example, how do you do a secure upgrade or update of your firmware on the sensor that not somebody else can do that instead of you? So these kind of things would need to be thought of. And actually I've seen there's one company in the research area on the back, they have software-defined basically sensor already, so I hope you have time to look at this during the day. Another idea is public IoT. So most of the cases, somebody deploys a sensor and also maintains the network and for one specific application. But imagine somebody deploys sensors around areas that can be used and accessed by everybody. So why would this be useful? The interesting thing is you could put these sensors next to roads and you could have cars connect to these sensors and the cars could potentially look around corners. right? So you could anticipate, is there a car coming from a blind spot? So these kind of things you could do with a sensor that is public. You could place these sensors in a city, and you can use your mobile phone to gather local information that is tied to location. Or you can place these sensors indoors and use it for indoor localization. So these kind of advantages you would have with the public IoT sensors spread around the world. Challenges are these sensors will, of course, be used way more often because everybody will use them all the time. You have to be careful that they cannot be spoofed, so not somebody else can like spoof a traffic measurement with saying it's safe, but it's actually not. These kind of things need to be thought of. And also, of course, who is willing to pay for them and put them and maintain them? This is another question, but this is actually another idea that could happen in the future. Mixed reality, of course, also a huge deal. On the right side, what you can see here is actually very interesting. This is NVIDIA's Omniverse. That's a software framework where you can model the world, and you can in real time look at wireless propagation. Right now, the example here is by Ericsson for 5G mobile communication, but you could also think about using this to model where to place the access points and where best to place the sensors, and in real time see in this like virtual reality environment what the best thing is to do. Again, this could simplify infrastructure setup and device placement, and also to reduce the cost, because you don't have to try it out. You can simulate first what you want to do, and then you can do it, and then you would see that this is good. So you only have to do this once. Challenges is you need an extremely detailed environment, and also you require specialized software. Like, for example, NVIDIA's Omniverse would be one of these things. Let me go a little bit quick, because I think we're a little bit over time. Quantum computer are going to break existing cryptography methods, basically. So what do? We have to still be able to send data in a secure way. Fortunately, research is actually looking at post-quantum cryptography methods. They're costly, but there's ways of making data secure, not just now, before quantum computers are really happening, but really like for the next 20, 30 years. This is another thing. And finally, I think this also fits well with the theme of this event. It would be very nice if we design IoT sensors that are sustainable. Say, for example, the coolest would be if they would be biodegradable. At a certain amount of time, they just would like basically compost itself and would be part of the environment. This could also mean that you could put these sensors in like protected areas, right? But the challenges, of course, are how would we even do that? I mean, even thinking about batteries, what kind of batteries could be used that are biodegradable? This is very difficult to do. And also, how do you make sure that the sensors still work for a long time and then suddenly deteriorate? That's very difficult to do. But this is just one of the things. This is probably a little bit far out, but this would be extremely cool if you could do that. So yeah, basically you see there's lots of exciting times ahead, and not just like in terms of like the next 5 to 10 years, but also in terms of the next few talks that we're going to see today. Thank you.
Thank you.